Hello everyone. So thanks for liking our videos, and today we are going to discuss two numericals which we have received over the mails asked by you. So let's start with the numericals first. So the first question which some of the students has asked, that if we have two coils, the inner one is having radius small r and the outer loop is having radius capital R. So how to identify the mutual induction between these two coils? So the way is very simple. The first condition that should be given in the question is R is very less as compared with capital R. So let us assume that the current in the bigger loop is capital I, and we have to identify the magnetic field at its center. So here the inner loop is having radius small r, which is very less as compared with capital R, and we have assumed that the current in the outer loop as small I. So we know that using one of the applications of Biot-Savart law, magnetic field will be given by, at the center of a current carrying loop, mu naught I upon 2R. We also know that the flux passing through a given area, let us suppose the magnetic field is almost same over this region because this loop is having very small radii. So flux passing through this loop will be given by B into area of the inner loop, and the area of the circle is pi r square. So the value of magnetic field comes out to be mu naught I upon 2R from the above equation into pi r square. We also know that phi is always given as mi. I gets cancelled from both the sides, so the value of mutual induction comes out to be mu naught pi r square upon 2R. And I hope you all know that the value of m is given by mu naught pi r square by 2R and having SI unit as Henry. Now next question which we have received over the mail is, what do you understand by Bohr magneton? So let me tell you what do you understand by Bohr magneton, or what we understand by Bohr magneton is, Bohr magneton is actually defined as the minimum magnetic moment of electron in the first orbit of hydrogen-like atom. So how to identify the magnetic moment? First of all, we know that for a current carrying loop, magnetic moment is given by I into A. So here magnetic moment can be written as I into A. The area will be given by pi r square. And we know that if an electron is revolving with certain speed Vn in an orbit around the nucleus, then the current will be given by E by T. So it will be E by T. Can I write, with your kind permission, pi r square as pi r into r? Now I am going to multiply it with 2 and I am going to divide it with 2. We know that circumference, which is 2 pi r upon time period, will gives us the speed, so it will be EVR by 2. Now I am going to multiply it with m and I will divide it with the same thing, because this MVR is nothing but given as angular momentum. So this minimum magnetic moment comes out, the magnetic moment comes out to be EL upon 2m. Using Bohr's postulate, we know that angular momentum must be an integral multiple of NH upon 2 pi. So this magnetic moment comes out to be ENH upon 4 pi m, and to have minimum value we know that n should be 1, so this is EH upon 4 pi m, and this is called as Bohr magneton. So thank you very much. Keep liking our videos and keep asking your questions so that we will keep posting answers for you. Thank you.